Tonight we're going to be looking at section 1.3, which is on measuring segments. Again, we're just introducing you to the very basics of geometry. So with measuring segments, we know that every point on a line can be paired with a real number. And we're going to call that real number a coordinate. So for instance here, we have point A, okay? And then we have little a, which represents the coordinate of that point, okay? So for instance, little a could be -1, okay? It could be 5, it could be 0, any of those. And then we also have point B with coordinate B. We're going to call coordinate B, for instance, let's just say that it's 10, all right? And if we want to find the distance between those 2 points, it's pretty simple. All we have to do is take the absolute value of their difference. Okay, and here it says A minus B, but it does not matter which one you do first, just as long as you take the absolute value. Alright, we cannot have a negative distance, okay? That doesn't make sense. So we have to make sure when we're taking distance that we always get a positive number. So for instance here, if we wanted to find the distance of segment AB, it would just be the absolute value of -1 minus 10. Okay, those are their coordinates. So that would be the absolute value of -11, which is just 11. Alright? You will not have to go through these steps every single time. A lot of times it'll be easy just to do it in your head, which I'm completely okay with. Just again, be careful with your negatives. So let's look at problem 1 down here. We want to find the length of ST. So we're going to find the length of ST on this number line. So there are a few different ways I could do that. Well, I could just count the spaces, right? So I could just actually count how many spaces there are. The only issue with this is be careful, because on this number line, for instance, we're counting by 2s. Some we may be counting by 1, some we may be counting by 5s, alright? So be careful with that. Or we can use the method from above, which says we just take the absolute value of -4 minus 8. Okay, -4 minus 8 is -12. So the length of ST then is just 12. 12 units here. Okay, our units here could be different things. They could be inches, centimeters, millimeters. It does not matter, but the distance of that segment is 12. Alright, next we're going to look at the segment addition postulate. What the segment addition postulate allows us to do is add together segments to get a full length, okay, a bigger length. The only thing about that is we have to make sure when we're doing this that we use collinear points, points that are on the same line. Because if the points aren't on the same line, then the segment addition postulate is not going to work. For instance, and this is going to be really small for you, but let's just say I had this shape, this angle here. I'm going to call this A, we'll call this B, and we'll call this C. These are non-collinear points. They are not on the same line. So when the segment addition postulate says AB plus BC equals AC, for this it would not work because AC is a different line, okay? It's not going to be equal. Alright? So this will not work. It is only for collinear points. So for instance, let's look at the bottom here. Problem 2, we are given that EG, the entire length of this bottom segment, is 59. And we want to know the length of the 2 smaller segments. Alright? So we know that we can add together the 2 smaller segments to get the whole entire thing. That's what segment addition postulate tells us. So we know that EF plus FG is equal to the whole thing, EG. So now we can just replace with what we know. We know that EF is 8x minus 14. We know that FG is 4x plus 1. Again, be really careful with your negatives here. And then we know that EG is 59. Alright, so now it's just an algebra problem. So we have 12x minus 13 equals 59. 12x equals 72. So x here equals 6. All right. Now, here is kind of the difference between algebra and geometry. We have to pay very, very close attention to what the question is actually asking us. All right, a little more carefully than we did in algebra. Here we want to know what EF and FG are. We do not really want to know what X is. X just helps us find those links. Okay, so we are not done. If you were to answer this on a test, I would have to mark off. It would have to be wrong because you did not answer the question. All right, so let's go ahead and find out what EF is then. So we're just going to substitute 6 in for X. So we have 8 times 6 minus 14. So now we have 8 times 6, which is 48, minus 14. So EF has to be 34. Okay. So now, once we find one, we have two options of finding the other. Either I can substitute 6 in and find FG, or I know the whole thing is 59, so I could do 59 minus 34 and find the length of FG. Either one would work, okay? And since I'm running out of room, I'm going to do this very smally up here, and I'm just going to do 4 times 8 plus 1. Again, you could have done it the other way as well. Okay, so 4 times 8 is 32, plus 1 is 33. So FG here is 33. All right, moving on. Congruent segments. Now we got to learn some symbolism here. Whenever you say congruent, you're trying to write it. Something is congruent to something else. We have a symbol for that. It is an equal sign, and then it just has a little squiggly on the top. Just like that. That means congruent. Alright? And so congruent segments are simply segments that have the same length. Okay, or have equal length. That's another way to say it. So if two segments both have a length of 5, they are congruent segments, all right? So the way we would write that, let's just say, for instance, XY is equal to 5, the length of that segment. Let's say that ST is also equal to 5, all right? If we wanted to write that they were congruent, because they have same length, we would need to write segment XY is congruent to segment ST. Alright, that's how we would write that. Okay, so let's look at problem 3. It says, are AC and BD congruent? Well, we need to know their lengths. So for AC, again, we can just count them. But what we're going to do here is use the absolute value again. Okay, so AC is -2 minus, be careful with your C here, that's 5. So AC is just 7. And then we have BD. B, again, be careful, is at 3 minus D, which is at 10, which is also 7. So since they have the same length, we know they're congruent. So AC is congruent to BD. Right? Moving on, that's really important. We'll use that symbol for congruent over and over and over again this year. Okay, the next thing we're going to look at is we're going to define a few more words for you guys that you've probably heard before. The first of which is midpoint. Okay, midpoint is a point that divides a segment into two congruent segments. Alright, that is what a midpoint is. So you can see down here in the picture, we have point B. B is the midpoint of segment AC. Okay, some more kind of notation with this. AB and BC, you see how they have those two red marks? Those marks tell you that those segments are congruent to one another. Alright? So when something has the same amount of marks, a segment, you know that those segments are congruent. Okay? But if AC, let's just say AB had 3, like that, and BC only had 2, those would not be congruent segments. They have to have the same amount. Alright, and then we're also going to go ahead and define a segment bisector. Okay? So a segment bisector is just a line, ray or segment, that goes through the midpoint. Oops. Okay. Alright, so let's look at an example. And this will be the last example for the video. Here we have point Q. Q is the midpoint of the segment PR. And then, so we would just want to find out the distances, the lengths of all 3 of those segments here. So if Q is the midpoint of PR, then we know that PQ and QR, those are congruent segments. I could have just as easily used one mark here. Just as they have the same amount of marks, it means they're congruent to one another. So if they're congruent, which they are, then we know that their lengths are the same. So I know that the length of PQ and the length of QR are equal. So now I can substitute. So I know that PQ is 6x minus 7. I know that QR is 5x plus 1. Okay? So I just substituted that in there. So now I just need to solve this. So subtract 5x, I get x minus 7 equals 1. So x here is just 8. Again, we're not done. We've only gotten to the beginning. So let's find PQ. PQ is 6 times our x, which is 8, minus 7. So that's 48 minus 7, which is 41. And we automatically know that QR is also 41. Okay? We know that because those are congruent segments. So if they're both 41, then PR has to be either 41 times 2 or 41 times 41 plus 41. Okay, so we know that it's 82. Alright, that was the last example. We're not going to have any try-it problems for this. It is a really basic section. What I do want you to do now is to go on to Math Excel, now that we have that up and running, and try the 1-3 in your homework section on that. See you tomorrow.